Hello, YouTube. This is Mr. Bakari, and today we are going to talk about transformations of functions. So, what we have here is our transformations laid out, and this would apply to any kind of function. You could square this, and it could be a quadratic, you could cube it, it could be a cubic, and so forth. But these are the rules, and this allows you to get the naming conventions for each of the transformations, which is super important. So if you haven't looked over this, this would be good to look over before we go ahead and we graph transformations. Okay? All right. So our first example is this function, which is a cubic. And it's essential to be familiar with the shape of the parent function before applying transformations. It's not mandatory, but if you have a good idea of what the parent function looks like, then it's going to make this a whole lot easier, and you'll be able to check yourself when you are done a lot more efficiently. So this understanding will also help you choose the most appropriate x values to include in your parent function table. So here's our parent function table down here. And as you can see, I've got the parent function graphed in red. Now, choosing the appropriate inputs would be depending on the function that you're graphing. So this is a cubic. So I want to make sure that when I cube my inputs, that they will fit in this window that I'm graphing in. Okay? All right. So to get started here, we're going to identify the horizontal transformations, which are inside parentheses, and vertical transformations outside parentheses. Now, vertical transformations apply to y, and horizontal apply to x. So that's what we're going to do. We're going to apply these transformations to our parent function table. All right, so remember with horizontal transformations, we must undo what's happening inside the function. So we apply the inverse operation to the x values. So it appears as x plus 3. So to undo that, we're going to do the inverse operation, which would be to subtract 3. So I'm going to come to my x column here, and I'm going to subtract 3. Okay? And I just write my rules up here, what I'm going to do to apply to the table. And then if you look at your vertical transformations, you're going to multiply by -2, and I'll put that in parentheses to show multiplication, and then add 5 to my y values. So both vertical and horizontal transformations must follow the order of multiply first, then shift. Reversing the order changes the outputs and gives the wrong transform table. So you want to be sure and apply the order of operations correctly. Okay, and then we just simply apply these rules to the table. So I'm going to go down my X column here, and I'm going to subtract 3. So that will give me -5, -4, -3, -2, and -1. Okay, so I'm subtracting 3 from all of my X inputs on my parent function table. Now I'm going to come over to my outputs, and I'm going to multiply them by -2 and add 5. So that's going to give me 21, and this will give me 7, and this will give me 5, and this will give me 3, and this will give me -11. Okay? So you can take your time with this, applying the rules. And now what we've got here is the coordinates of our transformed function. So that's what I'm going to come over here right now and graph in blue. Okay, so we're just going to transfer these over. So obviously -521 and -1, -11 are too big to fit in our window here. So we're just going to graph these 3 points. Okay, so let's go ahead and do that. So -4, 7 there, -3, 5, here, negative 2, 3 right here. Now, something to keep in mind, I'm going to bring our transformation rules out here. HK is your vertex or your anchor point, right? Where the graph changes directions. So HK. So in this case, if you look at our transformation up here, negative 3, 5, here's negative 3, 5 right here. Okay? And then the graph, I'm going to do my best to kind of show you shape here on a sketch pad, but the graph goes like so. Okay? And then in looking at your transformations over here, we can kind of verify that this graph has in fact been shifted left 3 and up 5. It has been vertically stretched by a factor of 2, and it has been reflected over the x-axis. So you can then look at your transformation and verify these transformations visually. Okay? All right. Let's look at another one. So for our second one here, we've got a cube root function. So I've got the parent function of a cube root, okay? And I've got the table. And what we're going to do is we're going to apply the transformations the same way. Now, I want to point this out. You do need to factor the inside of the parentheses when there are two terms, because the number in front is affecting both the x and the shift. So factoring separates the stretch compression from the shift so you can see the true transformations. So easy to remember, if you have two terms in parentheses or under a radical, you want to factor out the leading coefficient. Okay? So I'm just going to rewrite this function and I'm going to factor this. All right. Factor out the 4. What times 4 will give me negative 4? Negative 1. Okay? And so now that it's factored, I can see the true transformations here. This is a shift 1 to the right, and this is a horizontal compression by a factor of, remember, 1/4. Okay, so everything on the inside, we're going to apply the inverse operation. Okay, so again, I like to color code this just to kind of show what's going on here. These are our horizontal transformations. We'll apply them to X. These are our vertical transformations, and we will apply those to our Y values. All right, so here we go. So X, we are going to multiply by the reciprocal of 4, which is 1/4. And then we're going to add 1. And then Y, we're going to multiply by 1/2 and then subtract 3. Okay? So now we're going to apply these to our table. Now, typically I tell my students not to use mixed numbers, but here, since we're just using this as kind of like our notes to graph, it's perfectly fine and probably a better idea to represent these as mixed numbers as you're moving them over here and graphing them, okay? So let's go down and let's apply 1/4 of negative 8 plus 1, which will give us negative 1. And then 1/4 of negative 1 plus 1 is 3/4. Okay. 1/4 of 0 plus 1 is 1. 1/4 of 1 plus 1 is 1 1/4. And 1/4 of 8 plus 1 is 3. And then with our y values, we're going to multiply by 1/2 and subtract 3. Let's run through and do that really quick. I get negative 4. Here I get negative 3 1/2. I get negative 3, negative 2 1/2, and -2. Okay? And if you're finding, just the math a little challenging, you can pause the video. Encourage you to pause the video and do the math and then check with me your values. Okay, you want to take your time on this part because this is crucial because we're going to transfer these over and this is going to represent the transform function. All right. Now, once you're confident that you've done your math correctly, we're going to transfer these over. So I've got a point at -1, -4, 3/4, -3.5. Right here. 1, -3, 1 1/4, -2.5, 3, 2. -2, sorry. 3, -2. Okay, so I'm going to do my best again to kind of sketch this. And there is my graph. Again, HK, 1, -3. That's going to be represented right here where the graph changes directions. Okay? And again, you can kind of walk through the transformations. You can see that the graph has been shifted. We're comparing to the parent function here. It's been shifted right 1 and down 3. Okay? It has been vertically compressed by a factor of 1/2, and it has been horizontally compressed by a factor of 1/4. Okay? And we are done. All right, let's look at another one. So here is our quadratic. Again, parent function established. I've got my table, and I'm going to identify my horizontal transformations and my vertical transformations. Okay? Okay, remember, I just want to remind you that this applies to all functions. So it doesn't matter whether it's a quadratic, a cubic, a log, an exponential, absolute value. These rules apply to all. Okay, so this is a universal method that we use here. Okay, so I'm going to add 2 to my x's, and then I'm going to take my y's and multiply them by 3 and subtract 4. So now I'll go down the table and apply these. So that's going to be 0, 1, 2, 3, and 4. Over here, multiply by 3, subtract 4 will give me 8, -1, -4, -1, and 8. All right. Verify that our math is correct, and then we're going to come over here and plot our points. So transfer over 0, 8, 1, -1, 2, -4, 3, -1, and 4, 8. Okay. This is hard to sketch on my sketch pad here, so I am going to leave that up to your imagination here. But I'll just kind of make these points a little bigger so we can talk about this and see where our graph, what has happened here. Now, as you can see, the graph is a little bit more stretched vertically than our parent function, and that is because we have a vertical stretch of a factor of 3. Okay, if you look at HK here, 2, -4, our vertex has moved to 2, -4. Okay, that's a shift right 2, down 4, and there is our final transformed graph. All right. Okay, let's look at one more. And this is a square root function. Now, when I said earlier that it's important to be familiar with the parent function because you need to choose appropriate inputs for your table, right? So this is a square root. We don't want to use negative values because those would give us imaginary outputs. And we want to use perfect squares because we're taking the square root. So notice my inputs are 0, 1, 4, and 9. Okay? And I've got that graphed here. And as you can see, we do need to factor under the radical here because we've got two terms. So we've got to factor out that leading coefficient, that 1/3. So I'm going to go ahead and do that. Factor out the 1/3. Okay, so what times 1/3 will give me a positive 2? And that would be a 6. Now you always want to kind of verify that by distributing 1/3 back and verifying that yes, this is 1/3 x plus 2. Okay? So we are not altering or changing anything. We're just writing a factored form so that we can distinguish our transformations here. Okay? So I will color code this one more time. Horizontal, always inside or under your radical, X, and outside vertical transformations affect Y. All right, so let's finish this up. X, I'm going to multiply by the reciprocal of 1/3, which would be 3, followed by the opposite of adding 6, which would be subtracting 6. And then I'm going to multiply by -1 and add 2. Okay? So go ahead and apply this to your table, and then I will go over it in just a second here. Okay, 0 times 3, 0 minus 6, -6. 1 times 3 is 3 minus 6 is -3. 4 times 3 is 12 minus 6 is 6. And 9 times 3 is 27 minus 6, which would give me 21. Over here, I'll take the opposite and add 2. Okay, that one's easy. And we've got our transformed coordinates. Now we will move them over to our graph. So here we go. -6, 2. -3, 1. 6, 0. Okay, and 21, -1 does not fit on our graph. Let's verify our starting point in this because we've got a starting point with a square root function, which is -6, 2. -6, 2. So our graph goes like so. Okay? So let's review the transformations here. We've shifted left 6, up 2, and it's been reflected over the x-axis, and it's been horizontally stretched by a factor of 3. Okay, so as you can see, verify, does it look like it's been horizontally stretched? Okay, does it look like it's been reflected over the x-axis? You can verify these visually and then go and review your transformations. Okay? So this is how we go about doing this. Like I said, it applies to any functions. I'm going to make a follow-up video where we look at logs and exponentials so we can see how we transform these with asymptotes. And until then, take care.